Let's look at some examples that involve applications of inequalities. It says parking at a state fair can be expensive. A family wants to go to the fair and notices that parking costs $2 for the first half hour and $1.25 for every additional hour after that. A notice reminds fairgoers that a partial hour is charged at the full hour rate. Set up an inequality statement where T represents the time in whole hours. The family can afford no more than $10 in parking, so how long can they be at the fair? So ultimately, we want to set up an inequality and then solve it. But the first thing that we want to do before that is we want to define the variable that we're using. So let's use t, and that will represent the number of hours that the family is parked at the fair. And so we need to set up an inequality using the variable t. And in the statement of the problem, it says the family can afford no more than $10 in parking. So that means that the parking fees need to be less than or equal to $10. So in the line below that, I'm going to rewrite less than or equal to 10. And so we have to come up with an expression that represents the parking costs. Well, we know that the first half hour is going to be $2, and then it's going to be $1.25 for each additional hour there. So now that we have our inequality statement written like that, now we can go ahead and solve for t. So I'm going to go ahead and subtract 2 from both sides. And if I do that, we get 1.25. T is less than or equal to 8. And then from here, let me rewrite this inequality up above. And then I'm going to divide both sides by 1.25. And I did not multiply or divide by a negative, so the inequality symbol is just going to stay the same. So the calculator tells us that t would be less than or equal to 6.4 hours. However, we must remember that each additional portion of an hour, we get charged for an entire hour. And so we want to round that down to just 6. And let me show you why that is. So if we were to stay for 6 hours, then we would have 1.25 times 6, which is $7.50. And then if we stayed that additional half hour, we would have to add $2 to that, which is going to equal $9.50. So if I stayed any more, like even just a minute longer over 6 hours from this portion here, I would have to add another $1.25 to the $9.50, which would put us over the $10 threshold, or the maximum of $10. And so what we want to do is we want to ignore the 0.4 hours there. So for $7.50, this is for the 6 hours, and the $2 is for the first 1/2 hour. And so the question asks, how long can they be at the fair? So if we combine those two values, the family can stay parked for, you can either write 6.5 hours as a mixed number or 6.5 hours. All right, and that's how we figure out how long they can stay parked. Our next example says a family is moving from California to Idaho and they are trying to determine if it would be better to rent a Penske or a U-Haul. Those are both types of moving trucks. So Penske costs $109 per day plus 70 cents per mile. U-Haul costs $70 per day plus 90 cents per mile. Determine how many miles the Penske would need to be driven before it is a better deal than the U-Haul. I think one thing that we need to kind of assume about this problem is that it would cost, or we would be spending the same number of days in either of the Penske or the U-Haul. So let's just go ahead and assume that that's going to be one day. So it asks us to determine how many miles the Penske would need to be driven before it is a better deal than the U-Haul. So first, I'm going to create a variable m and have it represent the number of miles traveled. And so we want to set up an inequality where the cost of Penske is less than, because we want it to be a better deal, so it has to be less than the cost of U-Haul. And so we need to come up with two expressions that represent the cost of Penske and another expression to represent the cost of U-Haul. So it says that we have $109 for the day and 70 cents per mile for Penske. So if we're going to come up with the inequality for the cost of Penske, it would be 109 plus 0.70 m, where m is representing the number of miles traveled. And then we want that to be less than the cost of the U-Haul, which would be $70 plus 90 cents per mile. So now that we have our inequality set up, we can go ahead and start solving. So I want to get all the terms with a variable on one side of the inequality, and anything that doesn't have a variable, I want to get that on the other. So I'm going to do two sets of subtraction here. So these will give us 0. And then on the right side of the inequality, I would have 0.20 m. And on the left side of the inequality, we have 39. So I'm going to just swap the inequality around. So I'm going to put 0.20 m is greater than 39. And then I want to divide both sides by 0.20. And if I do that, we get m is greater than 39 divided by 0.20 is 195. So now I'm just going to go ahead and write a sentence out explaining the solution to our problem. So we would say the family would need to drive more than 195 miles in order for Penske to be a better deal.